Here's problem 25(6). An alpha particle, mass 6.7 times 10 to the minus 27 kilograms, Q equal to 3.2 times 10 to the minus 19 coulombs, has a speed of 20 kilometers per second at point A and moves to point B where it momentarily stops. Only electric forces act on the particle during this motion. Determine the electric potential difference VA minus VB. We're discussing an alpha particle which has 4 times the mass of the proton, 4 times U, and twice the charge. So we can imagine what this particle might look like. It's got 2 protons and 2 neutrons. So basically it is the helium nucleus. Total mass of 6.7 times 10 to the minus 27 kilograms. Like I said, basically 4 times the mass of a proton, and a Q equal to 3.2 times 10 to the minus 19 coulombs, basically twice the charge of a proton. So it's got 2 protons in there. Okay, let's find the kinetic energy at point A. Kinetic energy at point A is going to be 1/2 the mass times the velocity at point A squared. And that's going to be 1/2 times 6.7 times 10 to the minus 27 times the velocity, which is 20 kilometers per second squared. And if we calculate that, what do we get? I get 1.34 times 10 to the minus 18 joules. So that is the kinetic energy we have at point A. We come momentarily to rest at point B, so our kinetic energy at B is actually going to be 0. So our change in kinetic energy, which is our kinetic energy final minus our kinetic energy initial, the kinetic energy at B minus kinetic energy at A, will be a negative 1.34 times 10 to the minus 18 joules, because we have 0 minus this value. Alright, that's our change in kinetic energy. We know that in general our change in kinetic energy plus our change in potential energy will equal 0. So our change in potential energy will equal the negative of the change in kinetic energy. And that will be a negative 1.34 times 10 to the minus 18. So that's going to be a positive 1.34 times 10 to the minus 18 joules. That's our change in potential energy. Our change in voltage, our change in potential, will equal our change in potential energy divided by the charge. So that's going to be 1.34 times 10 to the minus 18 joules divided by 3.2 times 10 to the minus 19 coulombs. And what is that? .19 volts. Okay? That is equal to our final potential minus our initial potential. So that is equal to VB minus VA. But we want the potential difference VA minus VB. So if we have VA minus VB, that's going to equal the negative change in potential from our final to our initial. That's going to equal a negative 4.19 volts. So that's our answer. VA minus VB is a negative 4.19 volts. Answer.